back to Computer Graphics Laboratory with mini project, that is 17 CSL 68. Today we are going to discuss program number 8 as per your syllabus. It is experiment number 8. That is, develop a menu driven program to animate a flag using Bezier Curve algorithm. Right? Means we have to draw a flag, right? Then that flag we have to animate. Animate in the sense how wind, as per wind, how that flag is making a movement. That movement we have to show in our program. This is what he is expecting in this program. Again, you have to use the concept called Bezier Curve. Bezier Curve. Already we have discussed Bezier Curve in theory, right? Again, briefly I will recall the theoretical concept of Bezier Curve. Then we will move to directly program. Right? Then we will go to theory behind Bezier Curve. That is Bezier Curve function theory. Bezier Curve equations. As you know already, Bezier Curve equation, we have derived Bezier Curve equation in theoretical subject, that is 17 CS 62. Right? We first consider a general case of n plus 1 control points. Right? Again, whenever we are drawing Bezier Curve, we require control points. Right? As I told in theory, control points you require. N plus 1 control points you require. Then we can have dynamic equation of order n, right? That is what the expectation of Bezier Curve. N plus 1 control points denoted as pk, that is each pk means xk, yk, zk with k varying from 0 to n. Right? These coordinate points are blended to produce the following position vector. Means these coordinate points we have to blend, means we have to give the direction. We have to give the direction that is a position vector, that is a P of u, which describes the path of an approximating Bezier polynomial function between P0 to Pn. Means you have to start P0 here. If you see this Bezier curve, it has 4 control points, that is P0, P1, P2, P3, right? That is n plus 1, means n plus 1 here, 4 control points, right? Then we have to, every time we have to draw a point on this function till P0 to P3, till P0 to P3, that is P0 to Pn to P0 to Pn. Then every time you have to calculate points on this curve. That you have to every time, then when you are calculating that, you have to give a direction. You have to give a direction. For giving that direction, we have the Bezier polynomial function, that is this. This Bezier polynomial function will give the, this is called a blending function, it will give the positional vector. This P of u is a positional vector. Means where the next point will come, what the direction of that point when you are drawing this curve. Right? We have, by taking only 4 control points, we are drawing this Bezier. Means whatever point you are calculating here on this curve, those points should be controlled by these control points. Those points should be controlled by these control points. When you are drawing the point, then you must know whether it is following correct path from P0 to P3 or not. That path, that is path, how to calculate the path, whether it is following right path, that is the blending function will give the direction. The blending function, that's a P of u is a positional vector. Means every time this P of u, means whatever point you will calculate on this, that is a P of u, always will give the direction. Means if you know the direction, then you will come to know whether that point is following this, means it is moving towards P3 or not. It is moving towards P3 by controlling all 3 points. That is what blending function, right? Then this is a positional vector. Right? Then how to calculate, that is summation k equal to 0 to n, right? Means how many points you require to complete this curve. How many points you require to complete this curve? You can take any number of points. In our program we have taken 28 points. Means to complete this one curve, we have taken 20 points. We are calculating 20 points from P0 to P3. Right? Those 20 points will be controlled by these 4 points. Those all 20 points we are going to control by these 4 control points. Right? When you are taking individual point, that time those 20 points are following proper route towards P3, means whether they are going towards P3 or not, that has to be controlled by this blending function, that is Bz, that is pk. Pk is a point here, that pk is a point here, so that is following or not, that means that will be controlled by this function. Then whatever result this function is giving, that is the positional vector. That is the position, that is the direction, right? Then you use 0 to 1, use 0 to 1. Then the Bezier blending function, Bz nk of u, or the Brownian polynomial. What is that? This is nothing but this. That is here nk, then u to the power k, then 1 minus bracket 1 minus u to bracket to the power n minus k. This is what this. Right? Means we have to write a program for this actually. Whenever you are calculating, we have to write a program for this. Then program for this means this equation again. This is nothing but this. Then you take this value, then come multiply with your pk, multiply with your pk, then you will get the position vector. Right? But what is pu? Pu is nothing but this. Means every point, whatever point you are calculating here, every point has x, has y, has z. Right? Because 3D, every point is 3D point. Every point is 3D point. When you are calculating 3D point, what is the x direction, what is the y direction, what is the z direction? That is what. Right? This we are calculated. Then what is this C of nk? C of nk is this binomial coefficient. C of nk is n factorial by k factorial into n minus k factorial. Means that's why I told you have to write a program for this so that I can draw this line, right? Then as I told, what is pk? Every point on this line, every point on this curve is nothing but it has x, y, z coordinate. Every point is x, y, z coordinate. That's why I have to calculate. This has to be calculated for x, has to be calculated for y, has to be calculated for z. Then u varies from 0 to 1. U will vary from 0 to 1. That's why xk means pk. Pk is a general point. Then but pk has x coefficient, x coordinate, y coordinate, z coordinate. That's why xk this, then this one, right? Then yk this, then zk this. That's why I have to indirectly writing a program for this. Then every equation is explained here. Then for every equation we have to write a code here. Right? That we have done in this program. Then we will go to program. Right? First, before going to program, this is our output actually. Means I want output like this. This is a flag. Flag has to be animated. Flag has to be animated. Means it has to. When wind comes, then how flag moves like that. Our output must be like that. It has to move. Right? That's why. As I told, we have taken 4 control points. We have taken 4 control points to draw this flag. We have taken 4, that is P0, P1, P2, P3. Right? Then how we have drawn this flag? We will draw only one Bezier curve. We will draw only one Bezier curve which has 20 control points. I will go here. That's why this is control points. By using control points, you have to draw the Bezier curve. Right? We have, as I told, always Bezier curve requires control point. Then how many control points? That depends. We will prefer 4 control points. Right? We will prefer 4 control points. If you go for more number of control points, then complexity will increase. If you come for less control points, then approximation will not be proper. That's why ideal control points are 4 or 5. We will go for 4 control points. Then we will get a cubic equation. Right? Cubic equation. That's why. Then we will go how we are drawn. Actually, this is our output. Whatever I have shown, actually we have drawn like this. We have drawn those like this, but you will feel at the end, you will feel output like this. How we will feel output like this, I will explain in program. Right? Display. How to display this. Right? That is the display function. That is control points. Total number of control points. As I told, there are 4 number of control points. This is GL int n control points. N control points is 4. Means 4 control points we used here. Then n Bezier curve points. This is 20. Means to draw one Bezier curve. To draw this one Bezier curve, we are using 20 points on this. Means if you draw 20 points, then one Bezier curve will be drawn like this. Right? That is what total number of control points. You can take any number of control points. If you take more number of control points, you will get a smoother curve. If you take less number of, then you may get some staircase line curve. That's why we have taken 20 here. If you want, you can change in your program. Right? Means to complete this one Bezier curve, we have taken 20 points. Means there are 20 points on this Bezier curve. We have calculated those 20 points in our program. But we have taken 20, right? The static float theta, initially theta we have taken 0. Because again, this, what is the Bezier? This is sine wave. Right? We have sine wave like structure, that's why we are using sine wave. That's why we have taken a theta, initially theta is 0. Then WC 3D control point means we have taken one structure here. That structure I will show. That structure we have taken one structure, right? That is structure type dev struct 3D means so each point is x, y, z. Each point is x, y, z. That structure we have taken. That structure I have one variable we have created, that is WC point 3D control points 4. Then where is this control point? what is the coordinate values of this control point, what are the coordinate values of this control point, what are the coordinate of this control point we are defined here, right? First control point is in x 20, y 100, we have taken 3D, but z we are drawing at 2D. Control points while declaring, we have declared a 3D point, but ultimately we are displaying on a 2D monitor. That's why z is 0. Z is 0. That's why x of this control point is 20, y of this control point is 100, then z is 0. The next control point, that is 30. In x direction you have moved right side, that's why it is 30. Then in y direction 110. This is, if you compare this one, this is above. That's why 110. This point is 110. The next point, this is in x direction, it is 50. In x direction again you have moved right side 50. But compared to this is below, that's why this is 90. Y is 90. Y is 90. Then last point, this, that is 60 in x direction, you are here 60, then 100. Means in y direction both are at the same level. In y both are at, this is also 100, this is also 100. Only in x, first and last are, only their position is changing in the x. Y remains same, right? Means end points of the Bezier curve at the same line in y direction. Right? This is control point we have declared here, right? Then next, then will come, this is to animate, this is to just to make the animation, right? That's why this is a sine wave. This sine wave, just to make the animation we have taken this one, that is control point 1 dot x, control point 1 dot x plus 10. This will give, these values will change how much animation you want. Means how much, whether you want fast animation or slow animation or foldings, how many foldings you want, that will be given here. Means animation. Then this is a theta value. Again you may be knowing what is this, right? This is to convert radius to degree. Radius to degree we have taken initially theta is 0, then this sine, right? Always sine varies from 1 to plus 1 to minus 1, right? That sine value. That is, this value we have taken theta, sine theta. Then we have given theta value different phase angle, so that you can feel that the means that the flag is animating properly. This phase angle we have simply change the phase angle of sine wave, right? Then this is to number of foldings, means how fast you want that movement, that will be decided with these values. If you want, you can change these values also, right? If you want, you can change these values. If you change this one, then the that animation will be very fast, you will feel very fast. Then this, just to change the different phase angle, we have changed the plus 30, then same, then minus 30, like this. Again all control points you see here, only we have taken, here there are 4 control points, right? Here there are 4 control point 1, control point 2, control point 3, control point 4. But when you are giving the animation, we are given animation for only 3. That is, index starts from 1 to 3. Actually array index starts with a 0. Means 1, 2, 3 means only we have taken 3 points for animating. We have not taken first point. Why we have not taken first control point means, first control point is fixed to this stick, right? There is no movement of this control point. Always this control point is always fixed on this stick. That's why we are not changing the position of this control point in our program. This control point position must be always fixed, but remaining control point positions always changing with respect to these values. With respect to these values, always these control point positions dynamically they will change in our program. But the control point first, that 0th index control point is always fixed. That's why we are applying this animation to only 1, 2, 3 control points. We are not applying animation to 0th control point. This control point is always fixed, right? That will not change its position dynamically in our program. This is to just to animate this program, means to make a feel of that flag is with a wind effect, flag is making a movement, right? This will change the how fast you want. Then this is to change the phase angle of your sine theta, right? This is how we are drawn. Then how we have drawn this basically? This is the display function, right? This is our control point. Then just to make this animation we have drawn. Then how we have drawn in our program? How we have drawn in our program? We have used a push matrix and pop matrix. Here we are using push matrix and pop matrix. Push and pop always uses a stack. In last experiment we have told, means I have told a T-pod program. Means whenever you push the recent values of your operation, that translation whatever, that will be pushed. Then whenever you are popping, then very first top of the element will top of the content of the stack will come, right? Then how we have drawn, before going to this program, how we have drawn one Bezier curve right? We have drawn one. If you see this one, there are small Bezier curve, means there are many number of Bezier, means only we will draw one Bezier curve, just that Bezier curve will replicate. We will redraw same Bezier curve. Again I will redraw the same Bezier curve with changing the colors by change, because our Indian flag, right? Orange, again red, white, blue, or orange, whatever. Orange, we have taken orange color here, white color, then the green color. It is not Indian flag, but just we have eliminated one flag, right? Orange, white, then green, right? But by changing the every time means how many, after some Bezier curve, after some time, after number of Bezier curve drawing, I will change the color. Then after drawing n number of Bezier curves, I will change. How we have done? Only we have drawn one Bezier curve. Only we are drawing only one Bezier curve. That Bezier curve we are replicating to next, right? Then next like this. Then after some Bezier curve drawing, then I will change the color, right? Then again I will draw some same Bezier curve with some number. Then again I will change. That we have done here. That we have done, right? That's why since we use the position pop, it starts from this, then it draws up to this, right? Why it is starting from this means, here you see, here push matrix, then line width, right? Actually I have drawn this one, but since if you increase line width, that's why it will look like this. Actually we have drawn like this, but width of line we have, since we have increased, that every line is overlapping. Every line is overlapping. That's why you will feel like this. Ultimate output is like this, but actually you have drawn like this, right? Then line width we have increased. If you increase line width, automatically previous line and next line will overlap. Since there is overlap, then you will not fill this gap. Whatever gap you are observing in these two lines here, that gap will not fill, right? Then first color, orange color we have taken. First we have taken the orange color. To draw these portions, right? Then for I equal to 0, I less than 8, I plus 1, means 8 Bezier curves we have drawn. 8 number of Bezier curves we have drawn. If you increase this one, you will get width of this is high. That is, again you can change this weight also. Again you can change this weight. Means 8 times same Bezier curve I have drawn, right? That is GL translate. But how we have drawn? Every time first I will start here at Y sum, then next I have to come down. In Y direction I have to come down. That's why translate 0, there is no change in X. X remains same. X starts here only. X remains same. But Y will change. Means first if you have drawn somewhere here, then Y you have to drop below. Y have to drop. That is a translate. Means -8 means you are coming down. Then there is no change in Z. Because Z value anyway we have taken 0, because we are drawing in a 2 dimensional. That is Y translation. That's why Y translation. Then you draw Bezier curve, right? Then you draw Bezier. Afterwards we will go to this function. How we have drawn Bezier curve, right? Then I will draw Bezier curve, right? This Bezier curve will be drawn below. Then again next again one more time, 8 such 8 Bezier curves. So that's why again -8. Again I will come down. Again I will come like this. I will come down. This means after this loop completes, then I will draw orange color Bezier curves. All orange color Bezier curves I draw. Then afterwards, then I will go to next. Then I want green color. Then I want white color. Then I want white color. That's why I will set my color to white. We'll set the color to white. You know how to set this one, right? This I will set to white. Then again I will draw 8 such Bezier curve with white color. Right? Again I am coming down. That's why Y is -8 here also. Y is -8. There is no change in X. There is no change in Z. I am coming. If this is the Y, then I am coming from top to bottom. That's why 0 is here. This is maximum. Then you are starting from maximum to coming down. That's why you are doing -Y. Right? Then -Y. Then you draw first Bezier curve. Then up like that 8 Bezier curves you are drawn with white color. Then next with green color. Then I will set. After that again I will set the green color. Then again 8 such Bezier curves I will draw. Again Y minus. Because again I am coming down. Right? But while drawing this Bezier curve, it draws from this, because you are using the position pop matrix. It starts drawing from this green color, then it goes above, because you are using the position matrix. Code remains same, right? Then how to draw this, right? We have used for drawing. We have used the function called Bezier, that is control point, right? N control points, then N Bezier curve points. N Bezier curve points, right? Means I require N number of control points to draw. Then each control point you want to control, right? Total how many control points you use, right? Each control point you would like to control, right? Then how many control points? Then how many points you are using to draw this? These are the parameters we are passing for drawing a Bezier curve, right? Now we will go to Bezier curve function, right? right? Then before going to that, I'll again one more, that's here we have drawn this stick. You have to draw this stick, right? We have drawn that stick here. We have drawn that stick in this code, right? Color 0.7, 0.5, 0.3 with a different color. We have set the different color for that stick. Then line width we have taken little bigger width of line, because that it is a thicker line. Then GL begin, GL lines. Then it will start at 20, 100. First point of that line is 20, 100. Then next point is 20, 40. Right? Again it has drawn from top to bottom. Right? That is again x remains same, because in this x remains same. Here also same x, here also same x, but y is changed here, y is different here. That we have drawn that stick. That is 100 to 40. Right? You can change, if you want a longer stick, you can change the y value. Right? Then GLN, GL plus GL post display function, then blood short buffers. Right? Now we will go to Bezier function. Right? We will go to Bezier function, that is wide Bezier, as I told, control points. Each control point we have declared, right? That is CED, that is a control point, that is 20, 100, something control points you have taken, which control point you want to control. Then total number of control points, right? Then total number of points to be drawn to complete one Bezier curve, that we have taken. Then the Bezier curve point, that is a Bezier curve point, that is the points, how many points here. Then GL U you require, means U varies from 0 to 1, means when U varies from 0 to 1, when U is point 0 or point 1, then what is the point? Then when U becomes here, then what is the next point? Then when U means after this, U varies from 0 to 1. Right? That's why GL, again array declaration we have done. Then CL, n number of control points, that is a new array. This is array, we have assigned n control points. Right? Then to draw this, as I told, this is equation. Bezier curve equation is this, that is P of P equal to summation k equal to 0 to n, P of k, Pk, Bezier nk. We have to write a program for this. Right? In this, again this has different equation, that is C of nk, then u to the power k into 1 minus u to the power k minus n. I hope you remember this equation. This, right? This equation, again this is n of C of nk, u to the power k into 1 minus u to the power nk. First we will calculate this C of, again what is C of nk? This is a binomial coefficient. C of nk binomial. First we will calculate that one. Right? We are doing that one. C of binomial, that is binomial n control points, that is n control point minus 1, n control point minus 1 in comma C, means each control point, then total number of control points, that is the n. That this function we are plotting, then this value we have to multiply with this. This value we have to multiply with this. If you see this one, that whatever value it comes, then this has to multiply with this, then this has to multiply with this. Then this result we have to take and have to multiply with Pk. Right? That we are writing here. That we are doing here. That's why first we will calculate the binomial value, that value, then we will go to this program. Right? This is the binomial n c control point minus 1, that is comma C, then binomial. Then that is what is C of nk. C of nk is n factorial by k factorial into n minus k factorial. This we are calculating here. Right? That's why total number of control point, that is n, then first control point. Right? N is, that is 3, because n is 3. Right? N is 3, that is 4 minus 1, n is 3, then C, that every point. Why n is 3? Because as I told, first control point we are not changing, only 3 control point we are changing. That's why then again for k equal to 0, k less than or equal to n, k plus plus, then C of k is 1, then calculate C of k, that is n, here we are calculating n factorial here. We are calculating n factorial, that is j equal to n to j greater than or equal to k plus 1, j plus plus, you calculate the n factorial. Then you calculate the n minus k factorial, that we have done here. For j equal to n minus k to j greater than or equal to j plus plus, right? That we have done here. That is C. Then after completing this loop, then you will get C of nk. After completion of this loop, you will get C of nk, right? Then this C of nk we will take here, right? Then whatever it returns, that I will call, means every time whenever you call here, that it will calculate binomial. That for that point here you are calling, but particular point it calls, then it comes here. It comes here, then again it calls this function, then whatever value it comes, it takes. Then you are drawing using line strip. Line strip is first point to next point you connect, then next point to next point you connect, like this up to till last point you repeat this. Right? Then again come back to first point, line strip. Right? Again come back to first point. Right? This is what a line strip it does. Then for every point, then k equal to 0, k total number of points, that total number of points are 20, total number of points are 20, right? 20 times I have to draw this line strip, right? That is k plus plus, then u I have to vary. U means u initially 0, then it varies 1, right? It varies 1. Towards whenever you are, means we are drawing P0 to P1, that time 0 here, then 1 here. Then you start from here to here, then 0 here, 1 here. Then you start here, then 0 here, 1 here, like that. That's why 0, then I have to vary u fraction by, right? How we have varied the u, that is GL float k by number of points, total number of points, that is a 20, right? Then you will get a fraction of u, then at that point of view, what is it? Your p points. What are your control? What are your values? X, y, z. And u is something, for example, u is 0, right? K is here, first k is 0, 0 by 20, 0 by 20, then 0. At 0, what is your point? Then 1 by 20, 1 by 20, then whatever point fraction, then what is next to it? Like that, for up to 1, we have to calculate fill. That is what we are changing the u in. Then compute Bezier points. Now compute the point here. Then compute the point. Then compute next point. Like this, how many? All 20 points you have to compute. All 20 points you have to compute. Right? For one line. When you are drawing, because one time you are drawn. When loop is first time, you are drawing one line. Then for one line. Then like that, we have to repeat for 8 times. You have to repeat for 8 times. Right? Then here. Then we will compute Bezier. Now we will go to compute Bezier. It will calculate the Bezier value with respect to control points. It will calculate the point on this curve with respect to considering all control points. It will come here. You have to send the u, then and Bezier curve control points, then control point value you have to send, right? And control point, that control point, then total number of control points, then control point, then c. Now we will go to that way. Here we will go to this, right? Compute, yeah, u n points. Then here this is our u value, then point. Initially, what first control point, second, third. Again, anyway, we have not taken 0th control point. Only we have taken 1, 2, 3. Right? Then GL n control points. There are total number of n control points. Then that point, control points. Then C. Right? Then again, control points minus 1. Then we are writing. No, already we have calculated this. Already we have calculated this. We have to calculate now this and this. Then we have to multiply with this. We have to multiply with this. That we are doing here. Initially, Bezier points x, g. Initially, we will initialize 0. Initially they are 0, points are 0. Then for k equal to 0, k equal to n number of control points. Then the n number of control points 4, right? 4 times. There are 4. You have to consider 4 control points. Then by considering 4 control points, you have to calculate the new control point. Means every point on the curve has to be controlled by those 4 control points. That's why 4 times. Then Bezier blending function. What is that? That is this. Already I calculated this C of k. Already in binomial this has given. Then I have to calculate this one, u to the power k, that is power u comma k. Then I have to calculate this one, that is power 1 minus u to the power n k. We have calculated. Means you will get this. You will get this value. Then this is what? This is what your blending function. Then blending function has to be, if you see that equation, then that blending function for every k, every x, you have to multiply. You have to multiply and you have to add, right? That is summation. That equation, if you see this equation, this is summation, right? This is then every x you have to multiply k, then you have to do for all 20 values. You have to calculate for all 20 values, right? Then here that will be done. That will be done, right? Then control point k x, this x, then this value, whatever you calculated here, right? Then for every, then you have to repeat this one for how many times you are calling? You are calling it for 20 times. Here in this loop you are calling it for 20 times. You will call this for 20 times. This is all for 20 times, right? Then that will be calculated, right? Then after the execution of this, then you will get one full that line, one full curve, right? Then with respect to y, again you calculate y, that is yk into u. Already I calculated that way. Then z, then zk into this, right? You are doing that one, right? This Bezier of kn of u you have calculated here. Then that you have to multiply with x, y, z. You are multiplying here with x point, y point, z point, right? Then after this, then you will come back to here. Again you will come back to here. Again you will come back to here. Then after that you draw vertex. That means line strip means you draw vertex. You start at Bezier 4 point dot x, then 4 point y. 4 pointer point by point using a line strip. You start at first point, then calculate next point, then line strip will be drawn. Then calculate next point, then line strip will be drawn. Like this you are drawing this by using line strips. Means within a point you are using line strips. Right? It will draw 1 point. Like that you have to repeat. You have to repeat 8 times for one color. Then 8 times for one color. Then when you are drawing one curve, you have to draw 20 points. Then when you are drawing 20 points, each point has to be controlled by 4 control points. Because we have taken 4 control points. Then GL and delete up C means you remove that value whatever you have reserved for this. This is dynamic memory allocation. This is dynamic memory allocation we have done. Then this is what the Bezier curve function, that is a flag animation. Then for this you have again declared, this is declaration where some variables you have declared. Then window size means clipping window, all those things we have height, width we have taken. Then window minimum, window maximum we have taken, that is window. Then other code remains same, that is you have to use the get ortho 2D, GLE ortho 2D because this is a 2D. Then display function, then all remaining clearing the buffer bits and all those things, remaining code remains same. I already have sent the, I will give the detailed program on this. This is the explanation of this. Right? This completes your experiment number 8, that is flag animating. Thank you.